Hello, welcome to week 4 video notes 2. So just like last week, we are finishing up with our exponential functions with word problems. So here we are calculating exponential growth and decay word problems, just like we did last week. So in last week, we did them with COVID-19 word problems about the coronavirus. And this week, we're doing the same type of questions, but we are using different examples in our word problems here. So we still have the same formula. So just like you guys just saw in video 1, our A value is our starting value, our initial number. Our B value is the multiplier, that's the growth or decay factor. And then X is the number of times that it happens. So you guys were really good at this last week. So because we are using calculators with the exponent button, again, if you have an iPhone, I suggest you download the app called Calculator. And if you have an Android, I suggest you download Wabbit EMU. So Calculator for iPhones, Wabbit EMU for Androids, and that's a good free calculator for you guys to be able to plug in numbers very easily. So again, we're going to go through the odds together, and then you'll try the evens on your own. Make sure that you write all of the questions, all of the answers on your paper here. So all number 1 through 14 will be on your paper that you will submit for week 4 video notes 2. Okay, so number 1, it says there are 14 rabbits in a forest. They quadruple every year. How many rabbits will there be in 5 years? So again, A is my starting number. So I start here with 14 rabbits. B is my multiplier. My multiplier is that they are quadrupling. Quadruple means times 4. So how many rabbits will there be in 5 years? So we raise it to the 5th power. So we start with 14, and then parentheses 4, raised to the 5th power is the number 14,336. That is a lot of rabbits. We had a starting number, a multiplier, and a number of years. Go ahead and try number 2. An initial population of 750 endangered turtles triples each year. They're trying to save the turtles. It's tripling each year. How many turtles will there be after 5 years? So go ahead, try number 2. Number 3, a population of frogs decreases by 1/2 every year. If the starting number of frogs is 400, how many frogs will there be in 4 years? Okay, so initial, my starting number is that in this population there are 400 frogs. My multiplier is that they're being cut by 1/2 every year. How many years? The question is, how many will there be after 4 years? So I'm going to type that in the calculator. 400, open parentheses, 1/2 raised to the 4 years. And we end up with a good total of 25 frogs. There are 25 frogs in this decreasing population. So we started at 400, and then it went less and less and less. It decreased. Now we have 25 frogs left. Okay, try number 3. Number 3 says there are 270 fish in a pond. They reduce by 1/3 every year. How many fish will there be after 4 years? Go ahead and try that one there. All right, number 5. Number 5 says that the population of deer in a national forest has been declining by 1/3 each year since 2003, when its population was 1,944 deer. Predict the population of deer in the forest in 2008. So again, our A, our starting value, is that we started with 1,944 deer. My multiplier is that they are declining by 1/3 each year. How many deer will there be left in 2008? Well, we need to figure out the years here. So if we have 2008 and we're looking since 2003, we're going to do 2008 minus 2003 and end up with 5 years. So it wants to know how many deer are there after 5 years. That's how much time has passed from the start, which was 2003, till now, which is 2008. So I'm going to type that in, 1944, parentheses, 1/3, you could just put 1 divided by 3, that's 1/3, raised to the 5th power. So we started with almost 2,000 deer. After 5 years, we are down to only 8 deer left. So sad. I'm going to change colors, make it prettier. So we have 8 deer. All we have left, number 5. Okay, same idea. Go ahead and try number 6. We have a population of squirrels at a college campus that has declined by 1/2 each year since 2018, when its population was 800 squirrels. Predict the population in 2022. Okay, try number 6. It looks very similar to number 5. Okay, moving on to number 7. So now we are adding percents to our word problems. You did this in week 3. So if you did your week 3 work, this is going to be very, very easy. So anytime we see a percent in an exponential growth or decay problem, then we have to use this formula. It's the same. We still have a starting number, that's my A. I still have a multiplier, which is 1 plus whatever your percent is, or 1 minus growth or decay. And we still have raised to a power, and that power is the amount of time. Very, very, very similar to last week. Same idea as the first problems in 1 through 6. So number 7 says, Kristin invests $100 in a bank that gains 12% interest each year. Find the value after 50 years. So this is very common. So people have savings accounts. They put their money in a saving account. So this here, Kristin started with $100 in this bank account. So then it says it's gaining. Gaining is going to be 1 plus. So we use this formula. If it's a growth, it's a plus sign. If it's a decay, it's a minus sign. So this one here is gaining, so it's 1 plus. And then 12%, remember last time we said percents? You have to move the decimal 2 places to the left. So 12% is actually 0.12. And then the question, how many will there be after 50 years? So 50 is my time. So I'm going to type it in, 100. 1 plus 0.12 raised to the 50. Okay, so that's a big number. It gives us 28900.20. So this here, it says 0.218. So in this situation, we are talking about money. So with money, we're only going to end with 2 decimal places. But just as a quick lesson on rounding, so 0.21 are the last 2 decimal places. But if you look next to that 1, there's a number that's bigger than 5. So if you remember back in the day when we rounded in like the 5th grade, what happens is you have to have 2 decimal places because we're talking about money, so 2 decimal places. But if the number next to that second decimal place, if this number is bigger than 5, then we're going to take this 1 and round it up to a 2. Okay, so 28900.22. If you struggle with rounding, then email your teacher and see if they're available for an open Zoom conference, and we can definitely help you make sure that you get comfortable with rounding decimals. Okay, so try the same thing with number 8. Don't let the decimals scare you. Just practice the formula. What we care about most this week is that you can use the exponential growth and exponential decay formula. Okay, so try number 8, very similar. We start with an initial value. It's increasing. 0.85, you have to move that decimal 2 places to the left. So your R, your rate, your decimal is 0.085. How much will this piece of art be worth after 15 years? Okay, try number 8. Number 9, Elizabeth buys a laptop for $149.99. This laptop depreciates, that means it decreases 6.7% each year. Find the value of this laptop after 3 years. So I start with my starting number, which is 149.99. Okay, that's my initial price of this laptop. I have a 1. Depreciating means we are subtracting. Depreciating means it's getting smaller, so we have to use the minus sign. We have to move the decimal 2 to the left, so it's 0.067, just like we did last week. After 3 years, that's raised to the third power. Okay, so I'm going to type it in, 149.99, 1 minus 0.067, raised to the third power. So I end up with 100. So this laptop used to be worth almost $149. Now the laptop is only worth $121. Remember, 816. So money has 2 decimal places. The number next to it is bigger than 5. So I'm going to round this last decimal up to a 2. Because that last number was bigger than 5, it rounds my hundredths place, my second decimal, it rounded it up. Okay, so this laptop is now worth $121.82. Okay, try number 10. Jason buys a BMW for $25,000, which decreases in value by 23% each year. How much is this BMW worth after 10 years? Try number 10. All right, number 11. There were 500,000 typewriters purchased in 1970. Because no one buys typewriters anymore, they have decreased 18% yearly. How many typewriters will there be in 1995? Okay, starting value, easy. 500,000 typewriters. These typewriters are decreasing, so it's 1 minus. 18% is 0.18. So now I need to figure out the number of years. So I have 1995 minus 1970. So what I do to figure out the years, 1995 minus 1970. That's how I can figure out the years. And that answer is that there are 25 years that passed. So it's raised to the 25th. Okay, initial value, DK, raised to the 25. So now I type that in, 500,000 times 1 minus 0.18 raised to the 25th. So that leaves me with 3502.001, which is the same as just 0.00. Okay, number 11, very easy. Try the same thing with number 12. Sarah bought a fidget spinner for $9.99 in 2017. Because they are no longer cool, their value decreases 72% each year. How much are they worth in 2020? Go ahead and type that in and see how much you get. All right, next, 13. Last one for me to do with you. Number 13 says the population in Spring Branch was 5,678 people in 2012. The growth rate in this area is 27%. What will the population be in 2019? Okay, so I have an initial value. We started with 5,678 people in Spring Branch. This is growing, 1 plus, growing by a rate of 27%. So we write that as a decimal, 0.27. What will the population be in 2019? Well, to figure out the years, you take the year that they ended with, 2019, and you take away the year that you started, 2012. And that leaves you with the number 7. So 7 years have passed. 5,678, 1 plus, it's a growth rate, 0.27. How many is it after 7 years? How many people live here? So we have 30256.69134. That's the whole number that the calculator gives you. So this number here, it's people, population. How many people are there? So when we talk about people, we just ignore the decimal. We don't even have to worry about rounding because we're not going to round a person. So what we have here is when we're talking about people, that's a whole number, then we just keep it 30,256. Okay, so number 13 is my people. Last one, 14. Katie bought a new house for $278,000. Its value increases 8% each year. How much is her house worth in 10 years? So go ahead and use the same formula, very similar here. We're talking about money. How much is it worth? So you can have a decimal for number 14. Keep it nice and easy. Okay, so go ahead and try 14. So that is the end of what you have to do for week 4, nice and easy. You just had 2 video notes, one on writing the equation and one on exponential word problems. So hopefully you are very comfortable with this type of function. It's weird, it's different. So the big picture of today is that what you have is we have a starting number, that's my A value. You have a multiplier, it's growing or it's decaying, and it's always raised to the x power. So over the last 2 weeks, that's the formula that we've been playing with. It's called the exponential because it's in the exponent. So that's an exponential function. Okay, so that is the end of what we have for exponential functions for you guys. Next week, we will continue with something new. If you have any questions, email your teachers and they can help you out with whatever you need. Have a wonderful week. We will see you in week 5. We will be back for more online learning in week 5. Have a good week.